All right, let's go through the first few of these. What energy change occurs when chemical bonds are formed and broken? We have learned that breaking bonds requires energy, and making bonds releases energy. So I need to look for which answer is consistent with that. A, I'm going to reject because it has them doing the same thing. B, I'm going to reject because it has them doing the same thing. C, energy is absorbed when bonds are formed and released when they are broken. That is the converse of what is true. Released when bonds are formed, absorbed when bonds are broken. For question 2 here, what statement about exothermic reactions is correct? They have negative delta H values is indeed true. The products have a lower enthalpy than the reactants. My enthalpy diagram looks like that for an exothermic reaction, and the products are indeed lower than the reactants. The products are more energetically stable than the reactants. When you're lower on the ladder, more stable. So also true, all of the above. Number 3, when barium hydroxide and ammonium thiocyanate are mixed, a solution is produced and the temperature drops. As soon as I know that the temperature drops, if the surroundings got colder, it's an endothermic reaction. Endothermic reactions have positive delta H values. Okay. Number 4, for which of the following is the sign of the enthalpy change different from the other 3? So I'm looking for if we're breaking or making. Breaking is going to have a positive enthalpy sign because it's endothermic. Making is going to be exothermic. So for A, I'm breaking one compound into 2, breaking. B, I'm breaking sodium into a sodium ion and an electron. C, solid is breaking into gas. For D, I'm going to have one chlorine join up with another chlorine to form Cl2. We are making a bond and it's exothermic. Number 5, which statements are correct for an endothermic reaction? The system absorbs heat, true. Positive delta H, true. The bond enthalpy for the reactants is greater than for the products. Okay, now this is not an enthalpy level diagram, but if we're looking at the bond enthalpy total, we're looking at the bonds we break in the reactants and the bonds we make in the products. This step is endothermic. This step is exothermic. If I want to have a positive heat of reaction overall, then I'm going to need this term to be bigger than that term. So I'm going to need the enthalpy of the reactants to be bigger than that of the products. So C is indeed, or 3 is indeed true, making it all of the above. Number 6, this is a Hess's law question. I need to manipulate the top reactions to get the bottom reaction. So the top reaction, what does it have in common with the goal? Carbon. Correct number? Yes. Correct side? Yes. So I'm not going to do anything to the reaction or to the heat of the reaction. For the second reaction, what does it have in common with the overall? Carbon monoxide. Correct number? Yes. Correct side? No. I need to reverse the reaction. So reversing the reaction is going to give me positive Y. Now, summing these up, negative X plus Y, I want to look for which answer is consistent with that. No. Y minus X, indeed. Negative X plus Y is the same thing as Y minus X. Okay, last one in this section. I need to look at breaking and making. We have 2 H2 molecules. We have 1 O double bond O, and we are making 2 water molecules. So if I were going to tabulate the bonds I'm breaking 2 HHs and 1 O double bond O. HH has a value of X. O double bond O has a value of Y. We're making these bonds, 1, 2, 3, 4. 4 HO bonds, which has a value of Z. So that'll be 4Z total. Okay, now I need to figure out how to combine them. Breaking bonds is endothermic, so positive 2X, positive 2Y. I'm sorry, positive single Y. Making bonds is exothermic, so it'll be the 4Z will get a negative sign. And choice C is my answer.